Hello, welcome back. Today we're going to be focusing on scatter plots, which is going to start us off in our statistics unit and to end the year with it. So let's go ahead and get started. Our objective for today is I will be able to interpret scatter plots. So in case we forgot, a scatter plot is a series of sets of plots placed on a coordinate grid. So this right here is a scatter plot. And as you can see, it gets its name because all of these little pieces of data are kind of scattered throughout the grid. And so each piece of data is scattered across. And as you can see, there are no lines connecting any of these pieces of data. And that's the very important thing to remember as we talk about scatter plots. Alright, so when we have scatter plots, we can talk about their correlation. So when I think of correlation in scatter plots, I think of slope a little bit. So as we can see, this one right here is a positive correlation because it's going up, kind of like what SlopeTube would say. It's puff, puff, positive. It's going up the roller coaster or up the mountain. Okay, so it's a positive correlation because they're all kind of going up. This one right here is a negative correlation. If you had an imaginary line through it, it would be a negative slope. It'd be nice negative, or down the mountain or down the roller coaster, and they're all kind of doing that. So it's a negative correlation. And then when there's no correlation, or when you can't really draw a line any which way to describe it, it has no correlation. Okay, another way that we can describe scatter plots is linear or not a linear relationship. So linear line, we can think of it that way. You can see this one right here is a positive linear correlation. So it looks like a line. Once again, is a negative linear correlation, looks like a line going the other way. And then if there's not a linear relationship, it just kind of means that if it's curved, or in our last example, we had no correlation right here. Linear would be, they're all stuck together. They're all in a pattern like this one right here, but maybe it's curved or maybe bent. It looks like a V or a U. Those would be not linear or not straight. Okay, well, when we talk about scatter plots, and what we're going to focus on with scatter plots is line of best fit. And what to remember with the line of best fit is that we're trying to draw a line that best describes this data. And also a thing to remember about the line of best fit is it's not necessarily going to touch all of the points. So take a look at this one. Although it does go through quite a few plots, it doesn't go through all of them. It just helps us understand the data a little bit more. So if the data points are close to the line of best fit, it's said to have a strong correlation. So let's take a look at these examples right here. So these two top ones have a positive correlation, and you see our line of best fit is right here on this top one right here. But since the points are so far away from each other, it's said to have a weak positive correlation. On the other hand, a strong positive correlation is you can see all of the plots or the points are very close together and very close to the line of best fit. So that's why it's a strong correlation. And the same thing happens with the negative correlation. If they're spread far apart or not very close to the line of best fit, it would have a weak correlation. If it's super close, it would be a strong correlation. So we are going to kind of learn as we work on this in class, how we draw these lines of best fit and what they exactly mean. Alright, another thing to remember with scatter plots is sometimes we have a plot that doesn't seem to fit with the rest of the data, and that's called an outlier. So as you can see on this one right here, we have all of them that are very grouped together, and then this random one out here. Sometimes that happens when we were doing our hula hoop experiments. Sometimes maybe you accidentally dropped the hula hoop a whole bunch of times for one example, and the rest of them you were rock star. You did really awesome. And that happens sometimes with trials. Sometimes something random happens and it just doesn't seem to fit, and it's called an outlier. And that's why we do so many trials, is because sometimes the outliers happen and we don't want the outliers to mess up our data and all the rest of the data. Alright, so the U-try problem is pretty simple this time. We're going to ask ourselves for both of these graphs, the first one and the second one, the one on the left and the one on the right, is the correlation positive or negative, and is the correlation strong or weak? So please do not forget to write down any questions if you have any, and we will continue to work on this in class for the rest of the week. So thank you so much for being active listeners, and I will see you guys later. Bye-bye.